So let's determine the interval or intervals on which h of x equals 5xe to the negative x is concave up. Well, if the function is concave up, then its second derivative is going to be positive. So we're going to need to find the values of x that make the second derivative positive. Well, let's see what the second derivative is. If our function is 5xe to the negative x, then our first derivative, well, we're going to need the product rule because we have the product of 5x and e to the negative x. So the derivative of 5x is 5 times e to the negative x plus 5x times the derivative of e to the negative x. Well, the derivative of e to the negative x is negative e to the negative x because of the chain rule. Let's clean that up a little bit before we take the derivative and find the second derivative. So we have 5e to the negative x minus 5x e to the negative x. Now let's find the second derivative. So the derivative of 5 times e to the negative x, well, that's negative 5e to the negative x, again because of the chain rule. Now what about the derivative of negative 5x e to the negative x? Well, we're going to need the product rule again here. So the derivative of negative 5x, negative 5 times e to the negative x, and then we have our minus 5x times the derivative of e to the negative x, which is negative e to the negative x, again because of the chain rule. Now we can clean this up a little bit. We're going to have negative 5e to the negative x minus 5e to the negative x plus 5x e to the negative x. And combining these two terms, we have negative 10e to the negative x plus 5x e to the negative x. And that's our second derivative. Now we want to see where is that going to be positive. So first, let's figure out where that equals 0. And to do that, it's helpful to factor this. So what can we factor out of this? Well, we can factor out a 5 and an e to the negative x. So let's factor out 5e to the negative x. That's going to give us negative 2 plus x. So we could also rewrite that as 5e to the negative x times x minus 2. So that's the second derivative of x. And now let's see, where does that equal 0? Well, remember, 5e to the minus x, that's just 5 over e to the x. So we have 5 over e to the x times x minus 2. Well, e to the x is always positive. So 5 over e to the x is always going to be positive. So this is going to equal 0 only when x equals 2. So we have, let's make a chart here, and let's put the value of x at the top that make that second derivative equal to 0. And let's put our second derivative here in its factored form, so 5 over e to the x times x minus 2. And that equals 0 for x equal to 2. Now what about a value that's less than 2, like negative 100? Well, if x is negative 100, we already said 5 over e to the x is always positive. What about x minus 2? Well, that's going to be negative, right? So our second derivative is going to be negative for x is less than 2. What about x is greater than 2, like 100? Well, 5 over e to the x will be positive still, but x minus 2, if x is 100, that will also be positive. So we're going to have a positive times a positive. So our second derivative will be positive for x is greater than 2. And since we're finding the intervals on which the original function is concave up, we want the intervals on which the second derivative is positive. So that would be from 2 up until infinity.